BCPS family. My name is Mrs. Potter, and you're here for this week's episode of Algebra 1 BCPS-TV style. Beginning this week, we're going to start our episodes with some important mathematics messages from Dr. Jo Boaler, a professor at Stanford University. She's done a lot of research about learning mathematics. This week, we're going to learn from Dr. Boaler and some of her students about who can learn math.
Hi, my name's Jo Boaler, and I'm a professor of maths education at Stanford University. These are some of my students.
Hi, I'm Brandon.
Hi, I'm Elisa.
Hi, I'm Monse.
Hi, I'm Jody.
And we're here to tell you some really important and exciting facts about maths learning. The first, and maybe the most important, is that everyone can learn maths to high levels.
You may have heard that some people are math people and some are not, or that some people have a gift for math. But new brain research shows us there is no such thing as a math person. Everyone can learn math to any level they want.
Let's look at the brain evidence. We now know that experiences grow your brain. It is up to you how much you learn, as your brain grows and changes all the time.
When you learn something, a synapse fires in your brain. It's like an electric current. And when you learn something deeply, going back to the ideas and thinking about it, the synapse forms a new pathway in your brain. Synapses fire in lots of situations, not just in class. Pathways grow in your brain when you play a game, read a book, draw, and visualize.
Your brain is like a muscle. The more you exercise it, the bigger it gets.
In recent years, there have been stunning examples of what scientists call brain plasticity. Your brain isn't actually made of plastic, but it's so flexible, it's growing and changing all the time.
A few years ago, a 9-year-old girl named Cameron had half her brain removed because she was having dangerous fits that doctors couldn't control.
The doctors expected Cameron to be paralyzed for a long time, maybe forever, since she lost the part of her brain that controls physical movement. But she shocked doctors and scientists, as within months she was running around again.
The doctors could only conclude that the missing side of her brain had, in effect, regrown.
In another study, researchers found that a 3-week program in which people work for 10 minutes a day on a task caused permanent brain pathways to form.
Think about that. If a 3-week program can do that, what do you think a year of math class can do to your brain?
I'm so glad that you decided to join me today to continue exercising your brain in the area of math. Everyone can learn math at high levels, so all people are math people. Before we get to our learning objective for this week, let's talk about our Think About It task. This week's Think About It task is going to be a team effort. The task is asking us to find values that make equation A true and to find values that make equation B true. Before Team Potter tries to tackle this task, let's take a few seconds to think about it. All right, let's see what we can come up with. All right, let's start with equation A. A times B is equal to 20.
This is Victoria. 10 by 2 is 20.
4 times 5. And this is Lily.
This is Spencer, and 20 times 1.
This is Tim, and I think 6 times 3 1/3.
This is Finley, and I think 40 times 1/2.
So there are a lot of values that make equation A true, and I can even use the commutative property, and instead of saying 10 times 2 equals 20, I can say 2 times 10 equals 20. So there are a lot of values that make equation A true. All right, so let's take a look at equation B. We're trying to find two values for A and B so that A times B is equal to 0. So let's begin.
This is Victoria. 5 times 0 is equal to 0.
Thank you.
This is Spencer. 20 times 0 equals 0.
Spence, would 0 times 20 also be equal to 0?
Yes.
So the commutative property works?
Yes.
This is Lily. I think pi times 0.
This is Tim. I say 0 times 10 trillion.
Okay.
This is Finley, and 0 times 0 is equal to 0, but not 0 divided by 0.
That would be undefined. So 0 times 0 is equal to 0. So when I look at the values that we came up with that make equation A true and make equation B true, I'm noticing some things. What do you notice about the values of A and B that made equation A true and the values of A and B that made equation B true? I noticed that there were a lot of different values that made equation A true. And I can use the commutative property instead of saying 4 times 5 equals 20, 5 times 4 is equal to 20. But when I look at equation B, I'm noticing that one of the factors or both of the factors needed to be 0 in order to make equation B true. So in these first 3 examples, the second factor was 0. In the fourth example, the first factor was 0. And in the last example, both of the factors were 0. This is something called the zero product property, and we'll learn about that a little bit more in a second. The material covered in this week's episode is the same as the material in your print packet for Algebra 1 during the week of May 11th. Our learning objective today is to apply the zero product property and factoring techniques in order to solve quadratic equations and identify x-intercepts of quadratic functions. We talked a little bit about the zero product property in the Think About It task. Our new learning is going to be around factoring techniques. You've solved equations before. You've solved linear equations and you've solved systems of equations in previous work in Algebra 1. And we've identified x-intercepts of quadratic functions when they were written in factored form and when we looked at the graph. So today we're going to be identifying those x-intercepts strictly algebraically. And now let's learn about it. In this lesson, we will learn about solving quadratic equations. There are 2 different reasons to solve a quadratic equation. The first reason is to find the x-intercepts of a quadratic function. We know how to find the x-intercepts of a quadratic function if the function is written in factored form, but today our functions are going to be written in standard form. The second reason is to find the value of x in a quadratic equation in one variable. So similar, you learned how to solve equations, linear equations in one variable. So now we're going to be solving quadratic equations in one variable. So before I continue on, let's make a think about it connection. When we looked at equation A, which was A times B is equal to 20, it was true for many values of A and B. But equation B was only true when A, B, or both A and B were equal to 0. This is called the zero product property, and we're going to be using the zero product property today to help us both find the x-intercepts and find the value of x in a quadratic equation. The process of factoring is undoing multiplication. Factoring is the algebraic process that puts our equation in factored form, making it easy to identify the x-intercepts and to solve a quadratic equation. In this example from lesson 1, we're going to find the x-intercepts of the quadratic function f of x equals x squared minus 7x plus 12. In previous lessons, we found x-intercepts by either graphing or by looking at a quadratic function written in factored form. This function is written in standard form, so we're going to use an algebraic process to find the x-intercepts. All of my justifications or reasons are going to be on the left, and I'm going to do the math on the right. So let's start. The first thing that we need to do is replace f of x with 0 because an x-intercept has a y value of 0. So let's rewrite that equation. 0 equals x squared minus 7x plus 12. Now we need to identify the a, b, and c values. My a value is 1 because that's the coefficient of the x squared term right here. My b value is negative 7 because that's the coefficient of the x term. And my c value, is 12. That's the constant term. So the next thing I'm going to do is a little number puzzle, and this number puzzle has an important meaning, which we'll get to in a second. I'm looking for 2 numbers that multiply together to give me a times c and add together to give me b. A times c is 1 times 12, or 12, and b is negative 7. Oops, I wrote negative 17. Negative 7. The 2 numbers that satisfy this number puzzle are negative 4 and negative 3. Negative 4 times negative 3 is equal to positive 12, and negative 4 plus negative 3 is equal to negative 7. So my 2 numbers are negative 4 and negative 3. So now what I'm going to do is I'm going to write an equivalent form of the equation 0 equals x squared minus 7x plus 12 using the information from my number puzzle. I'm going to replace the negative 7x with a negative 4x and a negative 3x. Those two equations are completely the same, but by rewriting the equation in an equivalent form, I can use a process called factoring by grouping. So my equivalent equation is 0 equals x squared minus 4x minus 3x plus 12. So I'm going to rewrite my equation down here so that I can show you the process of factoring by grouping. The process of factoring by grouping asks me to look at my equation and to group it into two parts and find the greatest common factor of each of those two parts. My two parts are going to be the first two terms, which I'm going to highlight in yellow, and in this equation that is x squared minus 4x, and the greatest common factor of the second two terms, and in this equation those two terms are negative 3x and positive 12. So the greatest common factor of x squared minus 4x is x, and my remaining factors excuse me, are x minus 4, or x and negative 4. In my second two terms, I'm looking to make the second factor the same. So my greatest common factor is negative 3, and my remaining factors are x and negative 4. You might be noticing that there are two factors that are the same in each of the two terms in this new equivalent equation, x minus 4 and x minus 4. That's on purpose because now we're going to factor that greatest common factor from each of those two expressions. So my new equivalent equation is x minus 4, which is my greatest common factor of my first term, and the factor that's remaining is x, and I'm going to factor out an x minus 4 from the second term, and my remaining factor is negative 3. So this process allowed us to rewrite an equation written in standard form as an equivalent equation in factored form. And if you remember back to our previous lessons, we were able to identify the x-intercepts really quickly from a function written in the form f of x equals x minus r times x minus s. But I'm going to make a connection to the zero product property and show you how that helps us to identify any x-intercept with any equation in factored form. Before we move on to the last part of our process, I want to show you an alternate method for factoring. This might be helpful if you enjoyed looking at the box method in a previous lesson. So what I'm going to do is I'm going to take all of the terms in my equation that I rewrote using several b terms, and I'm going to put all of those terms in a box. So my x squared term goes in my upper left-hand box, my constant term goes in my lower right-hand box, and my x terms go in the remaining boxes. And now what I'm going to do is I'm simply going to factor a greatest common factor from every row and every column. So in this first row, the greatest common factor of x squared and negative 4x is x, and the greatest common factor of negative 3x and 12 is negative 3. The greatest common factor of x squared and negative 3x is x, and the greatest common factor of negative 4x and 12 is negative 4. And I can check and make sure that those factors result in the product that I put in my box by doing a quick check. So I have, again, an equivalent form of that equation written in factored form. Next, I'm going to use the zero product property because I have two numbers that are being multiplied together to give me 0. And I'm going to write two equations and solve each of those equations. So my first equation is 0 equals x minus 4, and my second equation is 0 equals x minus 3. I'm going to solve each of those equations. So in the left equation, I'm going to add 4 to both sides, and I get x equals 4. And in my right equation, I'm going to add 3 to both sides, and I get x equals 3. These are the solutions to this equation that I wrote way back up at the top. The 0 equals x squared minus 7x plus 12. But I actually wasn't asked to find the solutions to the equations. I was asked to find the x-intercepts of the function. So I need to take that information and rewrite them as x-intercepts. In this case, the x-coordinate of the first x-intercept will be 4, and the y-coordinate will be 0. And in this case, the x-coordinate will be 3, and the y-coordinate will be 0. So let's do a quick check and make sure that this works. Here's a graph of f of x equals x squared minus 7x plus 12, and I can see that my two x-intercepts are 3, 0, and 4, 0. Nice job. Before we take a look at another example of solving a quadratic equation to find values of x, let's do a fun think about it task. In this think about it task, there are 4 number puzzles up on the screen. I'm going to show you my thinking for the first number puzzle and then give you some time to try one or more of the other puzzles on the screen. So the first number puzzle is asking me to find 2 numbers that multiply together to give me 20 and that add together to give me 9. So in our Think About It task, when Team Potter was trying to find values of A and B that made equation A true, they gave us a lot of values that multiplied together to 20. 1 times 20, 2 times 10, 40 times 1/2, 4 times 5. So in my mind, what I'm doing is I'm thinking about all of those factor pairs and I'm adding them up. So 1 times 20 is 20, but 1 times 20 is 21, so that doesn't work. 2 times 10 is 20, but 2 plus 10 is equal to 12, and that doesn't work. But when I multiply 4 and 5 together, I get 20, and when I add 4 plus 5, that gives me 9. So my 2 numbers are 4 and 5. So take a few seconds to look at the other number puzzles on the screen, and in a moment, I'll reveal the answers. So in example 2, the 2 numbers that multiply together to give us 32 and add together to give us 12 are 8 and 4. In example 3, the 2 numbers that multiply together to give us negative 20 and add together to give us negative 1 are negative 5 and 4. And in example 4, the 2 numbers that multiply together to give us 18 and add to negative 11 are negative 2 and negative 9. I bet that you could make up your own number puzzle to try to stump someone at your house. Give it a try and see what they can come up with. In this next example from lesson 2, I'm asked to solve the equation 4x squared minus 8x equals 5. We're going to use a process very similar to the one that I used to find the x-intercepts of a function. There'll be a few small differences. So the first thing I'm going to do is rewrite this equation so that one side is equal to 0. And to do that, I'm going to subtract 5 from both sides. So my equation is x squared minus 8x minus 5 equals 0. This equation is equivalent to the original equation that I'm given. Next, I'm going to identify a, b, and c. A is equal to 4 because that's the coefficient of the x squared term. B is equal to negative 8 because that's the coefficient of the x term, and C is equal to negative 5 because that's the constant term. So the next thing I'm going to tackle is my number puzzle. I'm looking for 2 numbers that multiply together to give me a times c, which is the same as 4 times negative 5, which is negative 20, and add together to give me b, which is negative 8. Those 2 numbers are negative 10 and 2. Negative 10 times 2 is negative 20. And negative 10 plus 2 is equal to negative 8. So my 2 numbers are negative 10 and 2. So at this point, I'm going to rewrite the original equation, well, the first transformed equation that I have, into another equivalent form by rewriting the negative 8x as negative 10x and 2x. I'm doing this because I want to use a process called factoring by grouping. So I'm going to rewrite my equation and do my highlighting. So the first 2 terms, oops, I need yellow. The first 2 terms that I'm going to find a greatest common factor for are 4x squared and negative 10x. And the second 2 terms that I'm going to find a greatest common factor for are 2x and negative 5. So the greatest common factor of the yellow terms is 2x. And my remaining factors are 2x and negative 5. The greatest common factor of 2x and negative 5 is positive 1. and my remaining factors are 2x and -5. You might be noticing that there is a common factor in each of my terms, 2x minus 5. So I'm going to factor that out from the first term and from the second term. So when I do that, a 2x is remaining when I factor 2x minus 5 out from the first term, and a positive 1 is remaining when I factor out a 2x minus 5 from the second term. So I've rewritten my equation from standard form to factored form, and this will allow me to easily find the x-intercepts by applying the zero product property. Let's take a look at that alternate method for those of you that enjoy looking at this from a pictorial perspective or a visual perspective. I'm going to put the 4x squared in the upper left box and the -5 in the lower right hand box, and I'm going to put my -10x and my 2x in the remaining spaces. And now I'm going to factor by grouping each of the rows and columns. So the greatest common factor in the first row is 2x, and the greatest common factor of the second row is 1. The greatest common factor of the first column is 2x, and the greatest common factor of the second column is a -5. So my equivalent factored form equation from using this alternative method or this box method is 2x minus 5 times the quantity 2x plus 1 is equal to 0. And you'll notice that it doesn't matter which method I use, I'm still going to get the same factors. It's a personal preference, and you can use whichever method you're most comfortable with. So now I'm going to use the zero product property and set each of those factors equal to 0 and solve for x. So I'm going to add 5 to both sides, and I get 2x equals 5. Oh, that's tiny. And I'm going to divide both sides by 2, and my first solution is x equals 2.5, and my other equation, 2x plus 1 equals 0, subtract 1, so I get 2x equals -1, divide both sides by 2, 2x equals -5/10. So the two solutions to this equation are x equals 2.5 and x equals -5/10. So my final step is to just check to make sure that my answer is correct by substituting those values of x back into that original equation. So the original equation was 4x squared minus 8x equals 5. So what I'm going to do is I'm going to use my graphing calculator, and I'm going to substitute in each of those values of x into my equation and check to see if it's equal to 5. So I have 4 times 2.5 squared minus 8 times 2.5. And when I hit enter, that should be 5, and it is. So I check that first solution, and now I'm going to check my second solution. 4 times -5/10 squared minus 8 times -5/10. And when I hit enter, I should get 5, and I do. So there are the two solutions to that equation. Nice job. In both Lessons 1 and Lessons 2 of this week's material, the Triad activities are very similar. The first part of the Triad activity is going to ask you to find the x-intercepts of each quadratic function. Those quadratic functions are going to be written in standard form. Your job is to follow the procedure that's outlined in your print packet and that we did in the first example of our video to find the x-intercepts by using factoring and the zero product property. And your job is to check your solutions with the graphs that are at the bottom of that problem. The other type of question that you are going to be asked to do in the Triad portion of this week's print packet is to actually solve the quadratic equation. So that means find the value of x or the values of x that make the equation true. And there are 3 examples, and there are solution sets at the bottom that you can use to check your work. Now that you've listened to this week's lesson, you should be ready to tackle the problems in your print packet. Remember, it's important to exercise your brain. All people are math people. In our lesson today, we applied the zero product property and factoring techniques in order to do 2 things. 1, to solve quadratic equations, and 2, to identify the x-intercepts of quadratic functions. You should be ready to try the problems in your print packet. You got this. There are some great examples in your print packet for you to review if you need a structure to help you get started. Thanks for tuning in to this week's episode of Algebra 1 BCPS-TV style. I hope that you learned something new about solving quadratic equations and finding the x-intercepts of quadratic functions when they're written in standard form. Make sure that you share your new learning from this week with someone at home. Don't forget to spend some time outside this week and enjoy the fresh air. Bye!